In this first item of this first exam in Strength of Materials for spring 2015, note we got this aluminum, or rather steel band that wraps around this aluminum strut in the middle, and then we've got that whole system being pulled. Right, and we're asked to figure out what's the allowable load Q based upon the factor of safety 3 in the aluminum rod when it has a strength of 260 megapascals. Right? So the key here is going to be that we have to use statics to find the relationship between this applied force Q and the resulting axial force in the strut AC. We're going to do that using method of joints. So we're going to come along, create a free body diagram around joint B that will expose the force Q and the two forces AB and BC, and then we'll come down to joint A and do likewise a method of joints exposing AB, AD, and then the axial force in the aluminum N. Right, note that the geometric relationship here on the diagonal members is a 3, 4, 5 triangle, where 3 is on the vertical. Right. Equilibrium in the x direction is going to tell us at joint B that BC and AB x components have to be the same, and because they're at the same orientation, that means they are the exact same overall magnitude. That means we can go directly to sum of forces in the y, take upwards positive, we get Q minus 2 times the y component, 3/5 of AB. Right, so I simplify things down there already, and you get the result then that Q is equal to 6/5 of AB, or the other way around, that AB is going to be equal to 5/6 of Q. That allows us to come down here to joint A, and likewise, because AB and AD are the only two forces with vertical components, those vertical components are equal and opposite in their direction. Because they have the same orientation, 3, 4, 5, that means also that their overall magnitudes are the same. And that means that their x components will be the same. So when I go sum forces in the x there, take to the left positive, I have the axial force N on the rod pushing on joint A minus 2 times the x component, 4/5 of AB. Set it all equal to 0, and that tells me that the axial force is equal, in the aluminum rod, is equal to 8/5 of AB. Substitute in what I found out up here above, then we ultimately end up that the axial force in the aluminum is equal to 4/3 of the applied force Q, or the other way around, that the applied force Q is equal to 3/4 of the axial force N. Right? That means now I can go take a look at the allowable load in the rod. Since I know that the maximum stress is 260 and the factor of safety is 3, then I can find the axial force that's allowed in the aluminum rod is equal to the axial stress times that cross-sectional area, so 260 times 10 to the 6 newtons or square meters, that's a megapascal. Divide that by the factor of safety of 3, then multiply by the cross-sectional area of pi r squared. Right, got to remember to take the diameter, divide by 2. And someone made some sort of calculation mistake the first time through here. That will properly be evaluated as 39.2 kilonewtons for the allowed force in the aluminum rod. So then all we have to do to complete this off is to find Q. The allowable Q is to then multiply the allowable force in the aluminum by 3/4, and again the correct number here would be 39.2 times 3/4, and we end up with an allowable force in the whole system, or applied to the system that is, of 29.4 kilonewtons.